Hi everyone and welcome back to PrepFusion. I'm Anish and today we will start with the lecture 3 of our resonance chapter. So today we will mainly solve the assignment questions. So I will you can take the screenshots or you can pause the video and write out by yourself. I will show all the questions. This is the second one, this is the third one, this is the fourth one, this is the fifth one I guess, and this is the last. Okay, this is the I think seventh and eighth. This is the last one I think. Okay, you can pause the video, write out by yourself. Yes, this is the last. So I will start with this first question. So here we have to find out the quality factor of individual coil, each individual coils, and quality factor of the overall network. Okay, so individual coils you can very easily find out. So first of all, quality factor, right, is equals to what? Quality factor is equals to omega for a single coil, omega L by R. Omega L by R. Okay, so quality factor is omega L divided by R. So at what frequency? At what frequency? So if nothing is mentioned, by default you will assume it to be in resonance. If no frequency is mentioned, assume resonance. So for that I need to find out omega naught. Omega naught. Okay. So what is omega naught? Omega naught is 1 by under root LC. But if we see in the circuit diagram, I have multiple L's and multiple C's. So this formula will be what? This is a series RLC circuit only because these two are in series. These inductors are also in series. So it will be, as it is a series RLC, it will be L equivalent into C equivalent. The equivalent series inductance into the equivalent capacitive capacitance. Okay. So what is L equivalent? These two are in series, right? It will be 60 millihenry plus 40 millihenry. So L equivalent will be 60 plus 40 millihenry. Okay. So this will be 100 millihenry or 0.1 henry. Okay. What about C equivalent? So C equivalent, these two are in basically series, correct? These two are in series basically. So if these two are in series, so how can I further rewrite this? This will be, if capacitors are in series, it is C1 C2 divided by C1 plus C2. Okay, so C1 C2 divided by C1 plus C2, so it will be 1.5 microfarad into 3 microfarad divided by 4.5 microfarad. Okay, so C equivalent will be equals to 1 microfarad. This is your C equivalent and this is your L equivalent. Now just I have to put in the formula. Okay, so omega naught will be 1 divided by under root L equivalent into C equivalent. L equivalent is 0.1 and this is 1 micro. Okay, so it is 10 raised to power minus 6 basically. So it will be 10 raised to power minus 5, or it will be 10 raised to power minus 5 by 2 or 5 by 2. Okay, so this is the omega naught basically radian per second. Okay, so this value if I calculate will be 10 raised to power 5 divided by 2. So this is 316 something like that, correct? This is 360. Okay, sorry, this is for 10 raised to power minus 7, right? Why am I doing it 10 raised to power? This will be 10 raised to power minus 7 by 2 actually, sorry, plus 7 by 2. So 10 raised to power 3.5, it will be 3162.27. okay, this is your omega naught basically. So what will be my quality factor? Q1 will be omega naught into L1 divided by R1. This is the coil 1, This is the coil 1. So it will be omega naught is 362.27 into L1. L1 is 60 millihenry into 10 raised to power minus 3 divided by R1. Okay, R1 is 0.5. Okay, so this will be equals to what? So if I calculate this thing, this will be into 60 into 10 raised to power minus 3, okay, something divided by 10 raised to power 6 into 2. So this comes out to be around 0.3 something. Okay, something, have I messed up anything? Yeah, this is fine, this will, all these are fine, right? Something I have messed up, something I have messed up, I'm just checking. So this will be 3162.27 into 60 into 10 raised to power 3 into 2. So 379, almost equivalent to 380. Okay, this will be the quality factor of the first coil. Quality factor of the second coil will be omega naught into L2 divided by R2. This will be equals to 3162.27 into L2. L2 is how much? 40 millihenry, and R2 is 1 ohms. So 40 millihenry is 40 into 10 raised to power minus 3 divided by 1. Okay, so this will be 40 into 3162.27, 40 into 3162.27 into 40 into 10 raised to power minus 3. Okay, so this will be on the, okay, again I have made a mistake, like some calculation mistake. I am also not able to use the gate calculator properly. Something is happening with me, I am really phased right now. So into 10 raised to power minus 3, yeah, 126.49. Okay, so this will be your quality factor of the second coil. Now overall, what will be the quality factor? Overall quality factor, right? Overall quality factor Q will be overall inductance divided by the overall resistance. Okay, so it will be omega naught, that is 3162.27 into overall inductance is 100 millihenry, so that is 0.1 only, divided by the overall resistance. Overall resistance is 0.5 plus 1, that is 1.5. This will be 1.5. Okay, so 3162.27 into 0.1 divided by 1.5. Okay, so this will be 210.818. Okay, so this is the quality factor of the overall coil. Now let's say I want to redo this, right? I want to confirm, I derived another formula. What was the another formula? Q is also equals to 1 by omega naught RC. Correct, this also I derived because this came from this XC by R formula. So will it be valid here? Will it be same? We just want to verify. So let's verify. So this will be 3162.27 into C equivalent. What is overall C equivalent? Overall C equivalent is written here, right? 1 microfarad. So this will be 1 microfarad, that is 10 raised to power minus 6 into R. R is 1.5. Okay, so this will be 3162.27 into 1.5. Okay, my fingers are really messy right now, that's why I am typing the wrong things in the calculator and it is coming out weird. 3162.27 into 1.5 inverse into 10 raised to power 6. Yeah, this will be 210.819. Okay, so you will be very sad, upset, sir, they are not same. They are not same. No, they are same, right? So it is just almost near about approximation. But I think we have made a mistake. What kind of mistake we have made? So this is wrong basically. We have ignored this register, right? We ignored this value. This register value also we have to take. We have to talk about the overall quality factor of the entire network. They are not asking including the coils. So of course I have to add in this extra 4 ohm resistor. So if I add extra 4 ohm resistor, basically what will happen is my quality factor here, it will be this whole number divide by 5.5 basically plus 4. Okay, so this will come out to be, I think, around, let me just do this, point 316.227 divided by 5.5, so it is 57.4958, and here also I think we will get the same value only. We can again verify. So this will be again the same thing, except that in the bottom I will have a 4 ohm resistor. Okay, so this will be 3162.27 into 5.5 whole inverse into 10 raised to power 6. So this will be 57.496. Okay, these two are almost same. So just be careful about the mistakes, don't make the mistakes. Let's move on to the next question. So in the next question we have a series RLC circuit with resistor as this value, and XC and XL are this. Okay, they are same. XC and XL are same basically. That means it is in resonance. If magnitude of XC and magnitude of XL is same, that means it is the condition of resonance. What are they asking? They are asking it is connected across a 400 volt supply. So if nothing is mentioned, you will assume this 400 volt to be RMS. Assumption is it is RMS. They are asking me find the voltage across the inductor. Now I know it is in resonance condition. So if it is in resonance condition, I have derived you the magnitude of the voltage across the inductor will be Q magnified times the magnitude of the voltage across the resistor, or magnitude of the voltage across the supply. So I know the magnitude of the voltage across the supply, that is 400. I just need to find out the Q. Can I find out Q? Q is very simple, right? Q, the value of Q will be XL by R or XC by R. Both are same. So XL is 40, R is 20, so it will be 2. So Q is 2 basically. Q is 2. Okay. So my voltage across the inductor will be equals to 2 into the voltage across the resistor or supply, that is 400. So it will be 800. Okay, but there are two 800. Which one shall I choose? From the reference is basically my phasor, right? Will be something like this. This is my current, this is my voltage, input voltage, and I know the inductive voltage, inductance leads the current, inductive voltage leads the current, or inductor current lags the voltage. So if the voltage is here, it will lag, current will lag the voltage. So my VL will be here. So that means it is in the 90-degree leading direction. From current, it is in the 90-degree leading direction. Okay, so it is in the 90-degree leading direction plus 90. Okay, so option C will be correct. It should lead, the inductor voltage should lead by plus 90. Also you remember, right, your VL was equals to plus J Q into magnitude of VR. This also does the same thing only, says the same thing only. Okay, whichever one is suitable to you. Okay, I hope you have understood this point, why it leads and all those things we have already discussed. Let's now move on to the next question. So this question is very simple. So this question is here, a series RLC circuit has a bandwidth of 400 radian per second. Okay, so its bandwidth is 400 radian per second. Okay, its bandwidth is 400 radian per second. Its resonance frequency is 4000 radian per second, and it is excited by a 100 volt source. So the source, right, input source is 100 volts. Okay, if the inductance is 1 Henry, okay, L is 1 Henry, find the resistance R and voltage across the capacitor. So they have given me this, right, omega naught bandwidth. From this I will be able to find out the capacitance, but I will not be able to find out the resistance from this. But bandwidth has the formula for a series RLC circuit. For a series RLC circuit, I know the formula for bandwidth, correct? Formula for bandwidth in radian per second is R by L. So bandwidth is given as 4000 radian per second, and R I don't know, and L is 1. Okay, so of course my R will be 400 ohms. So R is 400 ohms. That was rather simple. What about the voltage across the capacitor? To find out the voltage across the capacitor, I know Vc will be minus J. Why minus? Because in the previous question it was plus J, because the inductor voltage leads the current, and here the inductor voltage, capacitor voltage lags the current, or what I can say is capacitor current leads the voltage. So that's why it will be minus J Q times the voltage of the supply. So Q will be what? Q will be very simple. Q will be equals to omega naught by bandwidth. Okay, so omega naught is 4000 radian per second divided by bandwidth. Bandwidth is 400. So this will be 10. Quality factor will be 10. So this value will come out to be Vc will come out to be minus J 10 into the magnitude of the voltage. Now what is the magnitude of the voltage? 100 volt, right? So it will be into 100. So it will be, they have not asked us like the phase, they have just asked us the magnitude actually, but that's fine, we will find out with the phase as well. So it will be minus J 1000 volts. So minus J 1000 and resistance is 400. So option C will be the correct answer of this question. Now what is the homework task for you? The homework task for you is to find the capacitance value. So this is the homework for you. Please put it down in the comments below. Put it down in the comments below. What is the capacitance and what is the omega H and omega L? Okay, put it down below. I hope you remember the formula. What was the formula for omega H? Omega H was bandwidth by 2. It will be plus because it is higher 3 dB frequency, plus under root bandwidth by 2 whole square plus omega naught whole square. What is omega L? Omega L will be minus bandwidth by 2 plus, like I am doing the homework for you, plus bandwidth. How do you remember? Because it is a lower 3 dB frequency, that's why there will be a negative sign here. Because it is a higher 3 dB frequency, that's why there will be a positive sign here. Bandwidth by 2 whole square plus omega naught square. Okay, so yeah, that was about the homeworks. I hope you can put it down in the comments below. Now let's solve this. Find the resonant frequency for the given circuit. So this is not a standard circuit, right? This is not a standard circuit. For this, how will you find the resonant frequency? So whenever some weird circuit is given, right, that is not standard, you have to just think, how can I make it purely resistive? How can I make this circuit purely resistive? So one thing can happen is that if somehow this whole thing is zero impedance, right? If this whole thing is zero impedance, then only this 10 ohm will be there and the circuit will be purely resistive. So first point you have to keep in mind to find out the resonant frequency is to identify how can I make the circuit purely resistive. Okay, that is what we have to identify. So how can I make it purely, like how can I make this zero impedance? So first thing is, this portion is only the resistive portion, correct? This portion is only the resistive portion. This portion I have to somehow make it zero. So if things are in parallel, how can I make it zero? If one of the branches has impedance as 0, then right, this whole thing will be 0 only, short circuit. because if one of them has zero impedance, all of the current will flow through that path. It will not choose the other high impedance path. So can I make this 0? Answer is no. I cannot make this 0 because this is just a capacitive reactance, and capacitive reactance at max, at omega equals to infinity, this can go 0, right? And omega equals to infinity is not present in the options. So let's think about this one. So here, what is the equivalent reactance that you are able to see? Equivalent reactance X is equals to what? XL minus XC, right? So I have to make it 0. If I make it 0, overall impedance is also 0 only. So again, same condition, XL is equals to XC, that is omega into omega naught into L, that is 4 Henry, equals to 1 by omega naught into C. Okay, so omega naught whole square equals to 1 by 4. Omega naught will be equals to 1 by plus omega, we will ignore the negative sign, because negative frequency we will ignore. It is 1 by 2. 1 by 2 is the answer, that is half. So whenever like these kind of simple questions will be asked, okay, but you have to use your brain. You have to use your brain. If you don't use your brain, then you will go wrong. Okay, just be careful. Don't always use the formula omega equals to 1 by under root LC blindly. See the circuit. Okay, let's solve this next question. So let me delete this. So this next question, given that the 3 dB bandwidth of the filter 1 is B1 and the filter 2 is B2, determine the ratio of B1 over B2. So what is the formula of bandwidth? If you remember, the formula of bandwidth is basically R by L. So if I see what is R by L for the first circuit filter, for the first filter, it is R by L1. Okay, so B1 is equals to R by L1. What about the second circuit? Okay, B2 equals to R by L2. So R by L2 is what? L1 by 4. It does not matter on capacitance, right? Bandwidth is independent of capacitance. So we don't care what is happening to the capacitance. Okay, so this will be R by L2. L2 is L1 by 4. So now if I take, what are they asking? They are asking the ratio of B1 over B2. So they are asking the ratio of B1 over B2. So this will be R by L1 divided by R divided by L1 divided by 4. So this will be L1 and L1 will get cancelled. It will be simply 4. So 4 will be the will 4 no right? It is 1 by 4. Am I correct? Yes, this will be, yeah, it will be 1 by 4. So this will be 0.25 basically. Okay. So I hope you understand why it is 0.25. So I hope you know how to take the ratio. Okay, I was also messing up, right? I was also messing up. Be careful with the ratios. Be careful. So this will be 0.25 only. So this will be the ratio of the bandwidth B1 over B2. Okay. So yeah, like few students might want to solve it using the quality factor. They can, because my quality factor, right? Because bandwidth is also equals to, like, quality factor is also equals to omega naught by bandwidth. This we can use, but the omega naught needs to be constant, then only I can directly relate the bandwidth and quality factor, else I will not be able to relate the bandwidth and the quality factor. So just be careful regarding that thing. Okay, we cannot simply relate the bandwidth and the quality factor. So this is my thing. You can say here that my bandwidth is inversely proportional to the quality factor. Okay, but certain condition is there that my omega naught must be constant. Okay, omega naught must be constant. That's it. So yeah, that's it basically. Now let us solve this next question. If the voltage source is given as this Vs of t 10 sine t plus 5 7 omega t, and omega represents the 3 dB lower cutoff frequency. Okay, omega represents the 3 dB cutoff lower frequency. So omega is here, that is a 3 dB lower cutoff frequency. So omega is omega L, that is equals to what? That is, what is the formula? Minus bandwidth by 2 plus under root bandwidth. This won't be required anyways, but I am just writing to help you memorize this. This won't be required in this question. This won't be required. Omega naught whole square, bandwidth by 2 whole square. So here we have to determine the average power delivered to the load. So this is the voltage basically, and we have to find out the average power delivered to the load. So power can only be consumed in the resistor, correct? If you notice, this sinusoid has a frequency of 1 radian per second. Okay, so whenever these kind of question comes, right, RLC, just check whether some resonance condition is matching or not. So if I notice what is the resonance frequency in this particular circuit, it is 1 by under root LC, which is 1 by 3 into 1 by 3, so which is 1 only. So this will be 1 radian per second. Okay, that will be the, this will be the resonant frequency for this circuit. This will be the resonant frequency for this circuit. Okay, so omega naught is this. Now what I can say is that this is the resonant frequency, right? So ultimately what will be the power consumed, because it will behave as a purely resistive circuit. There is a multi-tone signal. So first I will determine the power due to this, then I will determine the power due to this, then I will simply add. Why can I add? Because these signals are orthogonal to each other. Orthogonal. That's why I can simply add the powers. Got it? Now what do I notice? What is the power consumed due to this? It will be what? It will be the RMS value, voltage RMS value is 10 by root 2 whole square divided by R. Because the circuit will behave as a purely resistive circuit, this will cancel out. So this will give zero impedance. Ultimately this whole voltage source will be across the resistor only. So its RMS value will be RMS value of the supply whole square divided by R. So that will be the power consumed due to resonance. Okay, R is 1 ohm. So this will be 100 by 2, that is 50 watts. Okay, so 50 watts is the power consumed due to the first frequency 1 radian per second. What about the second frequency component? So in the question they have told me it is the half power point or the 3 dB lower cutoff. Okay, so what does half power point actually mean? What does half power point actually mean? Half power point means omega L and omega H is means basically power will be half of resonant power. Power will be half of resonant power, basically like the power consumed at resonant frequency. Power will be half of the power consumed at resonant frequency. So what is the power consumed at resonant frequency? 50 watt. So what you will do, you will write here 50 divided by 2 because it is a half power point, and it will be 25, and ultimately your power will be P1 plus P2, that is 25 plus 50, 50 plus 25, that is 75, and you will be totally wrong. Okay, you will see sir आराम से वो वाला क्वेश्चन कर दिया, बहुत अच्छा क्वेश्चन था. It was a very good question. I did it. Many students were not able to solve it. Many students were not able to solve. I was able to solve. I am very happy sir. Then I will say बेटा आपने वो किया क्या, आपने वो ख्याल रखा था. So what is the mistake here? The mistake is this, right? This is for the same source. For that same source. What do I mean by same source? So you have to assume a fictitious source of 5 sin omega t. If you have to assume if my omega was equal to omega naught, then what is the power consumed at resonance? Correct? This power was due to the 10 sin t, right? This is a separate source because its peak value or amplitude is separate. This is a separate source. Its peak value or amplitude is separate. Okay, so you are taking the resonant power of this source and then considering the half power of this source. That you cannot do. You have to consider the resonant power of the same source. So what if the same source, the source is 5 sin omega t, and if I assume my omega to be omega naught, then what is the power consumed? If I assume my omega to be the omega naught, then what is the power consumed? Power consumed is again RMS, VRMS whole square divided by R. R is 1 ohm only. So this will be 25 by 2, that is 12.5 watts. 12.5 watts. Okay, it is 12.5 watts. So next is, now what we have to do is we have to take this power. This is the resonant frequency power consumed. Now I have to halve it, because my frequency is actually not omega naught, it is actually omega equals to omega L or H. It is currently omega L, so it is omega L, that's why I have to halve it. So if I have to halve it, this will be 5, this will be 12.5 divided by 2 basically, so this will be 6.25 watts. This will be my P2. Now I can add my overall power P will be equals to P1 plus P2. Okay, so this will be 50 plus 6.25, so 56.25 watts. Okay, so this will be the answer of this question. So this is a very, very good question. Okay, let's now solve this next question. This is the last question of this lecture. So if the voltage source is given by Vs of t equals to 10 sin 3t plus 5 sin omega 1t plus 12 sin omega 2t. Okay, these are the different voltages basically. Omega 1 is minus omega 2 is 15, omega 1 into omega 2 is 9. Okay, this is the information that they have given us. And what are they telling? Calculate the average power delivered to the load. What will be the average power delivered to the load? So what is this 3? Is this 3 resonant frequency? No. Or yes, this 3 is resonant frequency. What is resonant frequency? Omega naught, if I find out, it is 1 by under root LC. So it is under root 1 by 3, 1 by 3, ultimately it will be 1 by 3 only. So this will be 3 radian. Radian per second. Okay, so this is my omega naught basically. Now what about the Vs of t and Vr, Vl, all these things? So they are telling me omega 1 minus omega 2 is 15. So what can I say is, an omega 1 into omega 2 is 9. So this fact, right, I know one thing, I know one relation, that omega h into omega L is omega naught whole square. Why? Because I have told you that the higher and lower 3 dB frequencies are the geometric mean. Okay, so omega naught is the geometric mean of higher and lower 3 dB frequency. So I can say omega h into omega L will be equals to 3 square, that is 9. So this equation is matching. What is this? So this is the difference of is this the difference of higher and lower cutoff frequency? That I have to cross verify first. So if you remember the formula, it was bandwidth by 2. Basically omega 1 minus omega 2, omega 1 minus omega 2 is basically what? The bandwidth of the circuit, right? Bandwidth of the circuit. Or if you remember, omega h is what? Sorry, not omega 1. Omega h is what? Omega h is bandwidth by 2 plus under root whatever that value. Omega L is what? Minus bandwidth by 2 plus under root whatever that value is. Okay, so when I subtract these two, so under root thing is common, so that will get subtracted. There is plus bandwidth by 2 minus of minus bandwidth by 2, ultimately it will club and it will become bandwidth. So what is the bandwidth? Bandwidth is R by L. So in this case R is 5 and L is 1 by 3, so it will be 15. Radian per second. So yes, it is matching actually. So basically omega 1 and omega 2 are basically what? My half power points. So from this conclusion I can say conclusively that you need two equations, because you have two variables. So of course you have to cross verify two equations. You have to match the two equations. So I can safely say that my omega 1 and omega 2 are half power points. Okay, so omega 1 and omega 2 are my half power points or half power frequency points. So like now I think I don't have to explain. So what will be the power due to this? This is just in resonance, right? In resonance the power will be the Vrms whole square divided by R. So divided by R is 5 ohms, so it will be 1 by 5 plus this is the what now this is the half power point, right? So I will first write the resonance power due to this. What is the resonance power? Vrms whole square divided by R, and I will multiply an extra half because this is a half power point. That extra half will be multiplied, plus again the second omega 2. Omega 2 again is the resonant power, so this will be 12, this is square, 12 by under root 2 whole square into 1 by 2. Okay, so this, right, this will be basically my answer. Now if I calculate the final answer, this will be 10 by 100 by 2, 50 by 5, 10 watts, plus this will be 25 by 2, 25 by 8, 25 by 8 will be around 3 point something, right, 3.125. This will be 4 into 4, so this will be huge number, 144 divided by 8, 18. So 28 plus 3.125, this will be 3.125 watt. Okay, so yeah, that is the case over here. This will be the answer basically. This will be the overall power consumed by the whole circuit. Okay, very simple, not that difficult to understand because you have already understood the previous question. Okay, so I hope you have enjoyed this particular lecture. If you did, make sure to like down below, and of course solve the homework questions and put it in the comments below. I will meet you in the next lecture with new topic, that is parallel resonance circuit. I hope you have enjoyed this lecture, and I will see you in the next lecture. Until then, happy learning.